In this video, we will talk about how to determine if a matrix is in reduced row echelon form. So we say that a matrix is in row echelon form, or REF as an abbreviation, if the following criteria are met. All rows of zeros are at the bottom of the matrix, and each pivot entry of a row is to the right of the pivot entry of any row above it. So remember, a pivot entry just means the first non-zero value in each row. Then we say that the reduced row echelon form, this is a little more strict. First, the first criteria is that the matrix must be in row echelon form. The next criteria is that all of the pivot entries are 1. So the first non-zero value in each row must be a 1. And the last criteria is that there must be zeros both above and below all pivot entries. So let's work through a few examples. All right, let's say we have the following matrix. Is this matrix in reduced row echelon form? Well, let's run through the criteria. First, we need to make sure, are all rows of zeros at the bottom of the matrix? Well, we can see that in this matrix, there are not any rows of all zeros. So by default, that criteria is met. Next, we need to check, is each pivot entry of a row to the right of the pivot entry of any row above it? So remember, a pivot entry is just the first non-zero value in each row. So in the first row, the first non-zero value, or the pivot entry, is this 1 right here. In the second row, the pivot entry is this 1 right here. It's the first non-zero value in the row. And in this last row, the pivot entry is this 1 right here. So is each of the pivot entries of a given row to the right of all the pivot entries above it? Well, we can see that this pivot entry right here is indeed to the right of this pivot entry above it. Next, we can see that this pivot entry is indeed to the right of both this pivot entry above it and this pivot entry. So we're good there. So the criteria is met. Okay, now moving on to reduced row echelon form, we saw that this matrix is already in row echelon form. Next, we need to check, are all pivot entries equal to 1? So we can see that each of the pivot entries that we identified, they are equal to 1. So that criteria is met. And lastly, we need to check, are there zeros above and below all pivot entries? So we can see for this pivot entry, there are zeros below it, and there's no values above it. And this pivot entry, we can see that there are zeros both above and below it. And in this last pivot entry, we can also see that there are zeros above and below it. So that criteria is met. So we would say that this particular matrix is in reduced row echelon form, or RREF as an abbreviation. Let's check out another example. Let's say we have the following matrix. Is this in reduced row echelon form? Well, let's run through the criteria. The first is all rows of zeros are at the bottom of the matrix. So we can see that there is one row of zeros right here, and it is at the very bottom of the matrix. So that criteria is met. Next, is each pivot entry of a row to the right of the pivot entry of any row above it? So in this first row, our pivot entry is right here, this 1. It's the first non-zero value in the row. In the second row, here's our pivot entry, this 1 right here. And in the third row, there are no pivot entries, since there are no non-zero values. So notice that the only one we need to check is this pivot entry right here to the right of the pivot entry in the row above it? It is. So we would say this criteria is also met. So moving on to reduced row echelon form, the first criteria is that the matrix is in row echelon form. So we saw that it is. The next criteria is that all pivot entries are 1. So we said that there were 2 pivot entries right here and right here, and we can see that they're both equal to 1, so that criteria is met. The last criteria is there are zeros above and below all pivot entries. For the first pivot entry, there are indeed zeros above and below it. For the second pivot entry right here, we can see that there's a 0 below it, but this is not a 0 right here above it. So that breaks the criteria. So we would say that this criteria is not met. So we would say no. This particular matrix is not in reduced row echelon form because it did not meet all of the criteria. All right, let's try another example. Let's say we have this matrix. Is it in reduced row echelon form? Let's run through the criteria. First is all rows of zeros are at the bottom of the matrix. So we can see that there's one row of all zeros, and it is indeed at the bottom of the matrix. So we're good. The next is each pivot entry of a row is to the right of the pivot entry of any row above it. So in the first row, our pivot entry right here is a 1, the first non-zero value in the row. In the second row, we have this 1 right here as our pivot entry. And in the third row, there are no pivot entries. There are no non-zero values. So we can see that this pivot entry right here is indeed to the right of the pivot entry in the row above it. So we would say this criteria is met. Moving on to reduced row echelon form, the first criteria is that the matrix is in row echelon form, which we just saw that it was. The second criteria is that all pivot entries are 1. Well, we can see that the 2 pivot entries that we identified, they're both 1, so we're good there. And lastly, there are zeros above and below all pivot entries. So for this pivot entry, we can see that there are indeed zeros below and above it. And for this next pivot entry, we can also see that there are zeros both above and below it. These are the only 2 pivot entries, so these are the only 2 that we have to check. So we saw that they do pass that criteria. So we would say that this matrix is in reduced row echelon form, since it met all of the criteria. Okay, let's try one last example. Let's say we have this matrix. Is it in reduced row echelon form? Well, let's run through that criteria. The first is that all rows of zeros are at the bottom of the matrix. We can see that there's one row of all zeros, and it is not at the bottom of the matrix. So right away, this matrix doesn't even pass this first criteria. So we would say no. We don't even have to go any further since this first criteria was not met. So we say no, this matrix is not in reduced row echelon form.